Hello, our lecturer and my fellow student. My name is Niyagisus Alfred from Group 8 Ecotourism, Park and Green Space Management. We are here as subgroup 5 to study about humidity. My group members, the first one is Niyagisus Alfred, Majambre Eme, Karekezi, Inosa, Uwimana Honorine, and Nyirahabimana Bernadette. Everyone here have a task to do or have what he started to tell you about the humidity. Let's go to the next slide for deep understanding about humidity. We are going to tell you about the introduction to humidity. I think everyone here, it's not the first time you hear a word humidity. When we say humidity is a concentration of water vapor present in air. A concentration of water vapor. I think everyone here knows what you call a water vapor. When we say water vapor is a water which is in a gaseous state. It becomes a gaseous state due to some factors, maybe temperature, pressure. There are many factors and presence of air that makes water to become in a gaseous state. And when we say water in a gaseous state, it generally somehow invisible to human eyes. Indicates liquids like precipitation, dew, or fogs to be present. I think everyone here knows what you call precipitation, dew, and fogs. I think we like to find the fogs in the early morning. Here in the next slide, you will be more understand about this term a dew, because we will find term what you call a dew point. Here we have illustration picture shows the how humidity it is. It looks like white humus. I think everyone here knows what you call humus. Humidity, as we have seen in the previous slide, it's like volatile water or water in gaseous state. Here you find that the white humus, but this white humus, it's a water vapor which is from the ground. Maybe it moves from the ground due to evaporation. When it moves from the grass, it's due to transpiration. Here we have term that express humidity. The first term we have absolute humidity. This refers to actual amount of water present in unit of air, usually expressed in gram per cubic meter or grains per cubic feet. That is how you measure absolute humidity. The second term we have what you call relative humidity. Relative humidity is a ratio of current absolute humidity to maximize possible absolute humidity. I think according to its explanation, it somehow have a relationship with absolute humidity because it depends on current absolute humidity to maximize the possible absolute humidity at a given temperature, and it expressed on percent, and it indicates how saturated the air in the water vapor relative maximum amount it can hold the temperature. Relative humidity of 100%, it means we have a full saturation, while low percent indicate we have dairy saturation. Here we have the picture that show the relative humidity. The first picture, we have a glass which contain an empty water. When it contain, it have 0%, it means it have low relative humidity. As we have seen, relative humidity it expressed in percentage. The second, you have some glass which is somehow half filled, where we have 50%, and the second we have relative humidity about 75%, and the last we have 100%. It means we have a full saturation. And the second, here we have another picture shows relative humidity. Here we have uncomfortable. When we have from 0 to 20, we have a dry. It means there is no water, there is no amount of water. The second, we have from 20 to 60, we have a compound range, where we have a water, or we have a relative humidity which is needed, which cannot cause a problem. And from 60 to 100 is another, we have an uncomfortable where we have too much excess water or too much excess wet condition, where it's uncomfortable. I think the normal relative humidity which is needed is from 20 to 60. But from 60 to 100 or from 0 to 20, it's a comfortable place.
I'm here by the names of Bernadette Nyirahabimana. I'm the member of subgroup 5 of climatology in ecotourism, parks and green space management. And I'm going to continue with the terms expression in humidity. I'm going to continue with the specific humidity. Specific humidity measures the mass of water vapor per unit mass of air. This means that when you are going to know the specific humidity of the specific place, we use the mass of water vapor per unit mass of air, and its unity, it is expressed in grams of water vapor per kilogram of dry air, which means that when we are measuring the mass of water vapor, we use gram, and when we are measuring mass of air, we use kilogram of dry air. It is an absolute measure and is not dependent on temperature. This means that when you are going to measure the specific humidity of specific place, we don't depend on temperature. We depend on water vapor per unit mass of air. Let's move on another slide. Let's continue with the dew point. Dew point is the temperature at which air becomes saturated with water vapor and condensation begins to form. At this point, air starts to become water. And at this point, it represents the temperature to which air must be cooled at constant pressure content to reach saturation. And another point is mixing ratio. Mixing ratio is the ratio of the mass of water vapor to the mass of dry air in given volume. It is expressed in grams of water vapor per kilogram of dry air and is another absolute measure of humidity. This means that the ratio of the mass of water vapor is measured using grams, and the mass of dry air in a given volume, it is measured by using kilogram. Here there is an illustration that shows the relationship between relative humidity and the dew point. When air temperature is 65 and dew point is 65, the relative humidity is 100%, which means that there is water vapor only. And when the air temperature is 80 and dew point is 65, the relative humidity is 60%, which means there is air temperature and water vapor. And when the air temperature is 90 and dew point is 65, the relative humidity is 44%, which means that there is air temperature also and water vapor, but at higher amount. Relative humidity is dependent on air temperature. Dew point stays constant. This means that always dew point stays constant, but the air temperature changes. Let's continue with the vapor pressure. Vapor pressure is the partial pressure exerted by water vapor molecules in the air. It represents the pressure exerted by water vapor component alone, regardless of presence of other gases in the air. And specific volume humidity is the volume of water vapor per unit volume of air, and it is expressed in cubic meters per cubic meters. Let us continue with the factors affecting humidity. The first factor that affects humidity is temperature. Temperature has a significant impact on the humidity levels. Warm air can hold more water vapor than the cooler air. As air temperature increases, its capacity to hold water vapor also increases, leading to decrease in relative humidity. If the moisture content remains constant, conversely, when air cools, its capacity for water vapor decreases, potentially leading to the condensation of high relative humidity. The other factor that affects the humidity is water source proximity. Humidity levels are influenced by the proximity of the location of bodies of water such as oceans, lakes, and rivers. Areas near water bodies tend to have higher humidity level due to the increased evaporation rates and moisture availability. Another factor that affects humidity is air pressure. Atmospheric pressure affects the saturation vapor pressure, which in turn influences humidity levels. Higher atmospheric pressure typically results in higher saturation vapor pressure, allowing the air to hold more water vapor and potentially leading to the higher absolute humidity. The other factor that affects humidity is elevation. Humidity tends to decrease with the increasing altitude. This is because the air becomes cooler as elevation rises, reducing its capacity to hold water vapor. As a result, relative humidity often decreases with elevation, leading to drier conditions in mountainous regions compared to low-lying areas. This means that at the place where there is higher altitude, the humidity tends to increase. Another factor that affects humidity is seasonal variation. Humidity levels vary seasonally due to changes in temperature, precipitation patterns, and atmospheric circulations. For example, summer months often experience higher humidity levels due to warmer temperature and increased evaporation. Winter months may have lower humidity levels due to the cold's reduced moisture availability. Thank you for your kind attention. Let my another group member continue with the other slides.
The next factor that influences the amount of humidity. First is vegetation and land use. Vegetation and land use can influence humidity level. Fourth, evapotranspiration, the combined process of water evaporation from surface and transpiration from plants. Dense vegetation can enhance evapotranspiration, increase local humidity levels, while deforestation or urbanization may reduce humidity by decreasing surface moisture availability. Second is the global climate patterns. Large-scale climate phenomena such as El Nino or La Nina can affect humidity level on regional and global scale. This climate pattern alter ocean temperature and attendance circulation patterns, leading to shift in precipitation pattern, humidity distribution. This is example of La Nina and El Nino. This is some question of these factors. Question and answer by using true or false. 1. Humidity is measure of the amount of water vapor present in the air. The answer is true. Second, relative humidity measures the actual amount of water vapor present in the air. The answer is false. Third is warmer air can hold more water vapor compared to cooler air. The answer is true. Fourth, absolute humidity is dependent on temperature and pressure. The answer is true. 5. Low humidity level can lead to increased evaporation rate. The answer is true. 7. High humidity level generally makes it feel cooler than its actual is false. 8. Humidity has no effect on the rate of rust formation on metal object. The answer is false. 9. High humidity level can contribute to growth of mold and mildew. The answer is true. 10. Humidity plays no role in formation of clouds and precipitation. Effect of humidity on both environment and human health. First is comfort and precipitation. Humidity plays a crucial role in human comfort precipitation. High humidity level can make a person feel hotter than actual temperature as measured by a thermometer. Due to reduced evaporative cooling, conversely, low humidity level can lead to sensation of dryness and discomfort, particularly in the respiratory system and skin. Second effect is health impact. Humidity level can affect human health in several ways. High humidity can exacerbate respiratory conditions such as asthma and allergies by promoting the growth of mold, dust mites, and other allergens. It can also contribute to heat-related illnesses such as heat exhaustion and heat stroke, especially in combination with high temperatures. Low humidities, on the other hand, can cause dry skin, irritated eyes, and respiratory discomfort. Third is indoor air quality. Humidity influences indoor air quality by affecting the growth of mold, mildew, and other indoor air. Excessive moisture can lead to mold and mildew growth, which can degrade indoor air quality.
Thank you. My name is Aime Majambere. So let us continue by showing you this table to show the optimum humidity which can be favorable for human being. So this optimal temperature, it range between 40 and 16. When it below the 40, there is a risk zone, and if it is above 60, it is another risk zone. So it must be between 40 and 60. So let's proceed by the effect of humidity on environment and human health. Another effect of humidity is agriculture and plant growth. Humidity levels impact agriculture productivity and plant growth. High humidity can promote the spread of plant diseases, fungal infections, and pests, particularly in crops susceptible to moisture-related issues. Conversely, low humidity can lead to moisture stress in plants, affecting their growth, flowering, and fruiting processes. Another one is weather and climate. Humidity is a key factor in weather and climate patterns. It influences cloud formation, precipitation, and the development of several weather events such as thunderstorms and hurricanes. High humidity levels contribute to the formation and precipitation, while low humidity levels are associated with skies and dry weather conditions. So another one is material degradation. Humidity can affect the degradation of materials such as wood, paper, textiles, and metals. High humidity levels and accelerate the corrosion of metals and the deterioration of organic materials due to moisture absorption. Conversely, low humidity levels can cause shrinkage, warping, and cracking in wooden structures and artifacts. Another one is energy consumption. Humidity levels impact energy consumption in buildings, particularly in HVAC, which means heating, ventilation, and air conditioning systems. High humidity increases the load and conditioning systems as they work hard to remove moisture, air for comfort, and indoor air quality control. So this is the summary of the effect of humidity on environment and human health. So as you observe, if humidity levels are too high, you run the risk of growing mold and bacteria, staph conditions, overall discomfort. So if humidity levels are too low, you run the risk of catching a cold or infection, dry and itchy skin, damaging the houses while sliding. So let us proceed to the tools to measure humidity. The first one is hygrometer. A hygrometer is a general term for an instrument used to measure humidity. There are various types of hygrometers available, each employing different. So the second one is psychrometer, also known as a wet and dry bubble thermometer. A psychrometer consists of two thermometers, one with dry bubbles and another with the wet bubbles covered in the moistened wick. It measures relative humidity. So the third one is hair hygrometer. Hair hygrometers are the principle of hair length changing the response of humidity fluctuations. A bubble of human and animal hair is attached to the mechanism that records changes in hair length and measure of relative humidity. So the fourth one is shielded mirror hygrometer. Shade mirror hygrometers use the principle of condensation on the temperature-controlled surface, the mirror, by cooling the mirror's surface until they form the dew point temperature in measured, allowing the accurate determination of humidity levels.
Okay, so we are going to see some of multiple choice questions about the effect of humidity and tools to measure humidity. First question, what effect does high humidity typically have on human comfort levels? The answer is decreases comfort. 2. Which of the following materials is most susceptible to damage in high humidity conditions? The answer is paper. What impact does high humidity have on electronics? Improves. It reduces performance. Battery rashes. Which tool is commonly used to measure relative humidity? It is hygrometer. What is the range of relative humidity typically considered comfortable for human habitation? It is 20% to 40%. We are going to see humidity in Rwanda. Rwanda level have varied depending on the region and the time of year. Rwanda's climate influenced by elevation, equatorial location, and proximity to the African lakes. Here are some key points about humidity in Rwanda. Equatorial climate. Rwanda has an equatorial climate characterized by relative stable temperatures. Rainy seasons. Rwanda typically has 2 rain seasons, the long rain season from mid-February to early June and the short rain season from mid-September to December. During this period, humidity levels are generally higher due to increased moisture from precipitation and evaporation. Topography. Rwanda's varied topography, which includes mountains, hills, plateaus, can influence local humidity patterns. Higher elevations may experience cooler temperatures and lower humidity levels compared to lower lying areas. Lake influence. Rwanda is bordered by several of the African Great Lakes, including Lake Kivu, Lake Victoria. These large water bodies can contribute to higher humidity levels regions through increased evaporation and moisture trendings. Dry season. During the dry season, particularly from June to September and from September to February, humidity levels may decrease as precipitation becomes less frequent. However, humidity can still be relatively high, especially in forested areas and regions near water bodies. Agriculture. Humidity levels play a significant role in Rwanda's agriculture, particularly for crops such as coffee, tea, and bananas. High humidity during the rain season provide favorable conditions for crop growth, while lower humidity than dry seasons may necessitate irrigation in some areas.